So, hi everybody. Welcome to this week's SQL and FHIR meeting. Let's get started. I know we wanted to have a Parquet focused discussion today, but wanted to just check in on some of the tasks outstanding for the milestone one. So I posted them in Zulip, but maybe let's just go through some of the action items. So we do have a review tracker. I'm going to post it in the chat as well. So feel free, if your name isn't on here, feel free to add yourself as well. So this is how we're tracking folks reviewing the spec and various components for milestone one. There's not a lot there. I looked at it today, but feel free to get started on that. And then we have an issue label or a label for issues and PRs in GitHub. So take a look at that. John, I don't know if you have any that we wanted to go through. It might be useful just to pull that up and have folks be aware of what's outstanding.
The main one that I'm working on closing out is the boundary functions thing, but unfortunately it's been a bit stubborn because nobody seems to agree on how it should work. But I think the other editorial one that is maybe not in a GitHub issue that I just noticed on the tracker there from you, Arjun, is a glossary. So that's something that maybe we should work on as well. But other than that, I think we're pretty close actually and on track.
Great. Yeah, that one is on me. I know you're sick of me hearing that, but I have to lock myself in a room to put up PR because I have the content for it. So I will very much try to do that. But yeah, so everybody take a look at those issues. John, for the boundary functions one, do we have a way forward? Are we engaging? Do we need a Zulip thread? How can we move that forward?
There is a Zulip thread that's on the FHIR path Zulip channel. Yeah, I think I just have to keep on going back. But anyone, please chime in if you have any opinions on it. But I think we might just have to get an agreed sort of set of test cases, because part of the problem is that the test cases and the examples are woefully inadequate. So we need a sort of much longer list of examples that we can all agree on what the right answers are, and then potentially we need to fix Graham's implementation and just make ours sort of reflect that, I think.
I think Igor, you're working on this as well, right? Okay. How about do we think people are aware of it? Because I haven't been tracking the thread in the FHIR path. Like, are people engaged with it? I guess is my question. Or should we advertise it a bit more?
I can post the link to the thread if anyone's interested in having a look. But I mean, it might be a great antidote to insomnia if you're like a sufferer of that.
I'm trying to figure out what levers to pull here. But yeah, maybe we just, take a minute and make a new Zulip thread, kind of put it in the top of folks' minds on this one. I know this one is just ongoing, so we should just focus on killing this one off. All right, so that's it for review tracker, the GitHub tag. And then I just wanted to really briefly go through, because we want to have that Parquet session. I posted a list of just outstanding to-dos, things that are rolling over. I won't read them all out here, but take a look at the meeting thread. And if your name is on it, maybe just take a quick scan. I don't think any of them are milestone blockers. I think those are all incorporated in the GitHub tag, but I wasn't sure. So yeah, maybe John, Bashir, take a look and see if any of those we need to highlight a bit more.
Yeah, I think if anyone's on this, probably just the action is to just reply to this thread and just say whether we can strike some of these off the list, and I'll do that as well.
Yeah, that sounds good, because I think some of them might be a little bit out of date, or at least out of date for us. All right, the only thing I think relevant was we had some ideas around testing, asking for some more example data and view definitions. So that can be an ask out to the group as a whole, not necessarily folks on this call, but just in general. I can put together a thread asking for more examples, since folks are starting to implement. We'll be developing examples and help share them. So I'll make that a to-do for myself to add a thread for more examples. And that's it, I think, for sort of housekeeping for milestone. Anything else from the group that we should be thinking about in terms of to-dos for the milestone release? We're doing a pretty good set. All right. If not, then let's move forward with, you guys wanted to continue talking about Parquet. I I don't have an agenda here, so maybe I'll just hand it over to you, John, if you had some discussion items you wanted to speak to.
Sure. So we've had a previous discussion in this space. What this is about is there, because a few of us have been working on SQL on FHIR, but in sort of implementation environment, which is taking advantage of like column representations of the data like Parquet, because it's particularly analytic focused. And a number of us have done different sort of parallel implementations of rendering FHIR
John
data.
froze up. You're back. Sorry, John. You froze up for me.
Okay. So we've done a number of different implementations of Parquet schemas, and we thought it would be a good idea to see what the differences are between these things and what they're for, what the different use cases are. Are there commonalities? Is it possible to create a sort of standard schema so that we don't have all these different divergent schemas? And we have a number of different examples of this. So Pathling is the product that I work on. Open Health Stack is the product that FHIR works on. Both of those originated from a library called Bunsen that Ryan worked on originally and had a Parquet schema in it. And these things were loosely based also on the SQL and FHIR v1 spec. And also some others have since then done other sort of takes on the schema like Microsoft and etc. The sort of difference, so the schema flexibility. So FHIR is based on resources, and these resources are based on definitions. And the shape of the data conforms to the definition, but the actual shape of that be infinite. We also have a lot of possible fields in the schema because of things like open types. So some elements can be any type, and there's like 20 or 30 types. So to create a schema that can truly accommodate any possible FHIR data, the schema is really quite large or technically infinite. So you have to take some sort of compromises there, like maximum nesting level and, which types do you want to encode and all this sort of stuff, which is a bit annoying, especially if you want to use it more for an interoperability use case, because then how do you know that the person who encoded this thing used the exact same sort of limits or whatever as the person who's consuming it? But that said, I think Parquet could be quite compelling as a way of passing data around, because extremely efficient both over the wire and to read data out of, and you can query straight off it, and all the analytic tools pretty much support it out of the box. So it could be, for example, data format to NDJSON. So anyway, we've got all this prior art. We wanted to do a bit more work on, well, can we address these sort of fundamental limitations in the file format, because this is a bit problematic. So I've been doing a little bit of experimentation on a new schema spec, which is based around the idea of a flexible schema. So the specification would define some rules around the schema. So this is how things must be represented if they are represented, but the presence of these things of elements within a FHIR resource could be optional. So one resource per schema. This is how each of the elements in the FHIR definition must be represented, and it's very close to JSON in that respect. So primitive elements, complex elements, extensions, etc. But if you have a data set that only has 5 elements, then could you pass this in a Parquet schema with just those 5 columns in it? Is the sort of fundamental question of this. And that this sort of gets around the problem of the infinite recursion and the open types and all of that sort of stuff, because the schema in any one instantiation of a Parquet file is fit to the data that it needs to carry. So then what you need to be able to do is, when you take that in, you need to be able to query on it in a way that is mindful that not all the fields are going to be there. And also, you need to potentially be able to merge it into other instantiations of Parquet data, which will have a different set of fields in that file. So that's basically been my experiment so far. Feel free to jump in, by the way, at any time with comments, but if I might just do a quick run through of where I'm up to with that, if that's okay. Yep, Bashir.
Yeah, thanks, John, for, well, first of all, for actually writing that down. I mean, that idea of, schema evolution, basically. Yeah, I have read your writing. The main reason that I haven't commented on it yet, I thought maybe it's easier to discuss some of the issues first, and then we can comment on the details on your writing. I mean, I think it's a good idea to go through what you have maybe quickly, in case that, I don't know, some people may not have read that. But I think there are maybe 2-3 core issues that need some longer discussion, and specifically, I guess the main one is this idea of schema evolution. So the main thing that I was wondering is whether, I mean, I actually like the idea very much, but I am wondering if the tools that process Parquet, how well they support schema evolution. And I haven't done much experiment with that, so I thought maybe while you are presenting, maybe you can comment on that as well.
Yeah, and I guess the other thing to discuss alongside that is in what use cases is schema evolution necessary. So Parquet is not really designed by itself to be an updatable sort of representation. It's primarily for analytic use. It's appendable. You can append to it pretty easily, although even appending to it can sort of put it out of shape and it needs to be redone at different times. And then there's been sort of enhancements to Parquet like Delta Lake, which make it more amenable to amending. And some of those implementations like Delta Lake have really good sort of schema evolution implementations to go with them for that reason. And that's actually the way that I implemented this schema merging proof of concept that I did for Pathling, because we used Delta Lake in this server implementation for fully updating that Parquet representation, including, all the statistics and everything that live inside that Parquet table. And it's also potentially evolving that schema as it goes. And the performance characteristics of this, by the way, are nothing like a relational database. Like it's slow to merge updates into a format like this because it's not really what it's designed for in the first place. However, it is a very valid use case to be able to, I've got this set of data here, now I want to put them together. And that could be just a part of an ETL pipeline, like I'm getting this data from this source and I'm getting this data from this source and I want to merge them together. So there are implementations that do this, but also, like the Parquet is a self-describing format, so it comes with a schema inside the file. So you can theoretically merge together. I mean, what all a merge is basically going through recursively and saying, what are the fields at this level? What's the union of them? Okay, go down into the next structure level and do that. So that's all a merge is. But I think, yes, you're right. We need to sort of see how hard this would be with other things other than Spark. One sort of point I would make, though, is this is also kind of the point of the SQL on FHIR view runner, I think. Because if you bring SQL on FHIR into this, I think this part of the value proposition of the SQL on FHIR view runner is that you don't have to over and over again re-implement the details of dealing with a base format like this. Like, I guess this is like just a different data layer format, I guess. So at the moment, we don't really have any standardization over the data layer. Like it could be NDJSON, it could be anything. This is kind of just a bit of convergence over one sort of flavor of the data layer, I think. But in practice, you would hopefully have a SQL on FHIR view runner that could work over this Parquet on FHIR, and it would be capable of being able to be tolerant to the missing fields, and it would also output simple views that don't need to be merged or anything like that. So anyway, that's just my sort of on that.
So I guess, yeah, I mean, it's probably best if you go once through your writing, and then we can discuss in detail. But specifically on the evolution, there are, I guess, 3 points that I have a little bit of concern or maybe questions. And maybe while you are presenting, maybe we can discuss those in more details. So the 3 things: one is the tool support, because I mean, Our thinking is a little bit different, I think, than your implementation. Like in Pathling is specifically based on Spark. And I think Spark probably has the best in terms of support for schema evolution and things like that. So our thinking was that, we generate Parquet and then people can choose what tool they use for querying Parquet. And that becomes like a important question, whether, other tools, like, I was just reading about it, like, for example, or Dask, this Python data analytics library. For example, I think they didn't support evolution very well, or at least had problems with like nested fields and things like that. So that's one thing. The other one is, your point about view definition is actually a great point. So maybe the ETL can support all of those complexities, and then it just creates like, that flat view and then internally handles that. That's a valid point. But one other use case that we have is, so some people write SQL against that wide format, let's say, right? And then let's say I have two schemas, one with column 1, column 2, another with column 2, column 3, which are compatible with each other. If I write SQL saying that, check column 2, if it's true, then aggregate on column 3, and I apply this SQL on the first schema, then I think it will fail, because if you see what I mean. So I am thinking that, those kind of scenarios, I'm not sure how well. If I want to have like one SQL, like a data quality measure, for example, and I want this to work on this Parquet format, then there might be issues if there are like missing columns and things like that. So I think that's the second point. And the third point, even for a Spark, I think you mentioned, it seemed to me that people are saying that this is potentially expensive. Like this schema merging. And I was reading like in Spark documentation, it was saying that they are turning the auto merge off by default because it's expensive. So maybe if you can comment on that as well. And thanks. I'll let you present your doc. Actually, I think it's a great idea for everyone to see.
Yeah, sure. Yeah, I'll also just preface it by saying that this spec sort of subsumes the full representation as well. So you can still have the full representation. Like, in fact, that could be like sort of a profile of this, if you like. Like you could still have an exhaustive representation of all or nearly all sort of possible data in the FHIR resource, very similar to what OpenHealthStack or Pathlink currently does, and still have it conform to the rules in this spec. And therefore you could have it potentially consumable by, simple clients and also smarter clients, but then you could have more minimal representations as well. So I just want to make that point as well.
Yeah, that's true, but we can't call it lossless anymore. So that's the thing. Like,
that's right.
With your idea.
That's right. Yeah. So basically, it's a reflection of the JSON format into a Parquet schema, really. And this is really Nikolai's idea. And I kind of pushed back on it early on because I thought, how's this going to work? But when I thought about it a bit more, I felt like actually this makes a lot of sense. So in the Parquet representation, say Pathling does, we have all sorts of ways of representing things like extensions, because so the other choice you need to make with something like this is it a general representation of a resource, or is it a profile specific representation of a resource? Because profiles have declared extensions. So if it's profile specific, you can maybe say, okay, well, we can expect this type of extension. We'll make a column for it, all that sort of thing. If it's not a profile specific representation, then you need to be able to handle undeclared extensions or any sort of extension content that might come through, or just drop extensions. So that's another sort of thing. So the way the Pathling schema works is that it can handle any type of undeclared extension. And the way that it does that is it sort of has field identifiers and a map at the base of the schema that you join into wherever the extension content needs to go. This schema is different in that it represents extension content in a very similar way to the JSON format does. So, and I might be skipping ahead here, but in JSON, extensions at the root are just held within an extension element. And of course, you can have any sort of data type here. In this schema spec, you do the exact same thing. So you have root level extensions at the root level. And if you had an extension in a complex type, you would again have an extension child of that complex type. And theoretically, this means that there's an extension column within every single complex type in the schema, which would be absolutely terrible if you were trying to create this as one giant schema that accommodated everything. But if you're not trying to do that, then maybe that makes a lot of sense. And I'll talk about annotations in a minute as a way of pulling this stuff out into top level elements if it's something that you want to frequently use. But that's one of the differences with this. And the other thing is primitive extensions, which I haven't seen any solution to this actually. Technically in FHIR, you can actually extend primitive values as well. And the way that they do that in JSON, for example, is they have this underscore convention, and you can, for example, extend birth date with like a birth time. And that actually becomes pretty easy within this scheme too, because we can again mirror the structure of JSON. And by the way, going really close to JSON is really valuable because you can use something like JSON schema inference with Spark, or other tools have it as well. And it will basically just spit out something that is already compliant to this scheme. Shane.
Yeah, I was just going to make a little comment on what we decided to do with primitive extensions as we map incoming JSON objects into tabular format for Redshift. So basically, if a field is meant to be primitive and there is an extension in that, basically we strip out everything except what was meant for the original primitive and store that in the primitive, but then we maintain the original incoming field with its extension. We put it in kind of like an overflow field. So that might be an option here. Like if you want to stick with like basic primitives in certain fields for FHIR resources, but then also be lossless, you can kind of move it into its own place where it can be stored in a more flexible way. Did that make sense?
Yeah, thanks for that. That's interesting. Yeah, one of the sort of main design sort of principles I took with this was stick as close to the original format as possible and then have an annotation mechanism. So you'll notice with these primitive element data types, almost everything is a string except for integers. And the reason for that is that similar to the JSON format, there is a prescribed data format in the FHIR specification for everything anyway, and it doesn't and there are semantics with it. So for example, you can have dates, you can have partial dates, and you need to sort of interpret those things in the right way. And if you sort of just convert, say, a FHIR date into like a native date or a timestamp, you're actually losing some data there because you're losing the original precision of how that data was captured. So I think a better way is to have a mechanism for annotating that data with additional representations that might be easier to query. So for example, so that's why I've got this section down here called annotations. And I've sort of started it off with a few sort of standard ones that you almost always need, right? So you can store any date time in FHIR as like either a full to the millisecond ISO sort of date, or you can store it as some sort of partial. And that's a challenge when you're querying things because you're querying different things of the same type, but they're to a different precision. So if you want to say, okay, well, from this date to this date, how do you do that if it's just a year, you know? So, and also it may not be very efficient to query data that's held in a string format. It might be more efficient to, for example, have a timestamp typed field in your where clause than some sort of date string that you have to sort of parse on the fly. So like I've got this sort of concept of standard annotations that cover sort of common use cases for dealing with the FHIR data types. And this is really from a original idea by Dan Gottlieb, which he did in his Sync for Science project, of a whole sort of set of standard ways of annotating FHIR data to make it easier to query. Yeah.
So just to clarify, these annotations are arbitrary, or are you defining like a standard set of annotations per data type?
I think there's a standard set of annotations, but you can also have your own annotations, right? If you use the things in the standard namespace, they have to have standard semantics, right? So these are things that we think there is common value in, but there's also probably annotations that we haven't thought of that. But if you use this convention, then there won't be a clash between column names. It'll be in that sort of annotation space. And as long as you don't name your annotation the same as some other annotation, then you should be able to define whatever annotations you like.
I see. Yeah. Okay, thanks.
The other one is decimals. So, and this is sort of a known problem with FHIR JSON format, actually, because they took the decision to use like a JSON number. Can be a bit problematic because there's this whole idea that, you know, preservation of precision in healthcare is important and all this sort of thing. But it's not always preserved that well through implementations as a JSON number. So anyway, in this representation, we're saying keep the decimal as a string for the original representation. So whether that comes in as JSON or otherwise, you can represent it faithfully in that string, including the original precision scale that it was captured at. And then you can annotate it with a numeric field so that, again, you can query it in a numeric way, etc. And in this case, we've just got a numeric annotation field that goes alongside that. And the final one that I came up with, which is something that we do in Pathling, which is quantities. So quantities can have standard units. So they can use, for example, UCOM, which is the standard terminology for units. And what we can also do on the way in is we can canonic quantities if they're in using standard units. And this allows you to do comparisons between different types of units. That was in Celsius. And we had a body temperature observation in Fahrenheit. If you have something that understands UCOM, you can, on the way in, annotate both of those quantities to have a canonical representation that might be in Kelvin, for example. And then you've still got the original thing, but you can compare the two Kelvin quantities. You can say, give me all the records that had an observation of over this sort of value in Kelvin. And instead of pointing to the original one, you can point to the annotated one. And obviously that's not always possible because not all things are comparable, but those are just sort of some examples of annotations. So yeah, it's pretty straightforward. I think I actually went through yesterday and created two fully worked examples. So the first example is a patient resource, and this one's good because it has extensions in it. So this is one resource, right? Obviously, in practice, this would be more of a data set, if you like, but there is a corresponding schema that could accommodate this resource, right? And you can see that the birth date, because this is a date field, we've annotated this with start and end timestamps. But because they've got this, we know that they're not FHIR elements there. The second example is an observation, and this one's good because it has a few more of the data types. So this is a body temperature annotation, a body temperature resource, and again, we're just going through and encoding all the present fields as a Parquet schema, annotating dates where we see them. And here we've got a quantity, and we've annotated this whole quantity with a second canonical quantity where we can put canonical quantity information as well. And I also went one step further than this and did a bit of an exercise on whether this would actually work, at least within the context of Spark. And I certainly take your point, Bashir, that other implementations, DuckDB is the one that's next on my list, would potentially have different considerations here. But what I did from a Spark perspective was that I created two condition resources that have sort of totally different data in them. So they've both got a subject, but they've got different styles of reference. So one of them's got an actual logical, a sort of relative reference, and one's got an onset date time, one's got a recorded date. So the thing I'm trying to figure out here is like, if I took each of these data sets separately and encoded them as Parquet, then I would get two different Parquet files with two different, right? And I'm talking about encoding it with a scheme similar to what I've said. And I've actually just done that largely through JSON schema inference, because JSON schema inference actually gets you very close, if not all the way to this scheme. So if I brought these both in, I'm actually using delta here to merge them in, and then it's taking this one and saying what columns are missing in the first one that I need to add, and then I can basically append this data to the table. And this is sort of the result of this. So this is the schema of the second resource. As you can see, it's quite different. Merge these fields at the top level, but also inside the structures as we go down. So you can see that here, like we've got a reference that has to have merged into it the reference and etc. So in that case, this is what delta is doing for us. So whether we can do this manually, that's the other sort of assumption I wanted to invalidate was, can we query over data if we don't know whether a column's going to be there, right? Because you want to have one implementation that can query over a schema that conforms to this spec that is not just going to break if it tries to, if somebody queries a column that's not there. In fact, what we want from a SQL on FHIR view runner perspective is for it to return an empty collection effectively. So if the column's not there, we want it to basically treat it as the absence of that value in FHIR, and we want to return an empty collection from a FHIR path point of view. So, and that's very simply handled in something like Spark. We can effectively, because as I said, Parquet is self-describing. In Spark, you can access the schema of the Parquet file that you're reading. And this is simplified in that it's only doing it at the root level, but you can do that as you go down as well. And you can simply say, if this thing that I'm looking to query is in the schema, then return it. If it's not, then return a literal null or a literal empty array, or however you want to represent the absence of a value. In this query, if I had tried to select foo without this little safe column bit, then I would have got an error because it would say foo is a missing column. But if I have this little extra bit of logic, I can get null back or potentially an empty array back instead. So that's the type of thing I'm envisioning that we would build into our SQL on FHIR view runner to have to be tolerant of compact schemas, I suppose. So that's pretty much all I wanted to show you. Is there any questions?
Yeah, thanks. Thanks again, John. I think this is great, both the writing and also the experiments that you have done. Again, thanks for doing the work, actually. So I think, just to pose some questions, and maybe then afterwards, we should also spend a few minutes at the end, discuss how we want to move forward. Whether we want to continue in this meeting or have a separate, a working group to answer the questions. But so I think that the first, fundamental question is, what are the use cases? So what do we want to use the Parquet schema for? And I can see at least two kind of separate use cases, and then the requirements for them would be different. One is as a vehicle, like NDJ for bulk. So when I do a bulk export, I create Parquet file. So it's basically just a file format just to move data around. Another use case is that I want to feed the Parquet files without modifications to any tool that understands Parquet and then query. And that's a fairly different use case. Because some of the issues that you mentioned, the missing column, for example, is more relevant probably to the second one. For the first one, you would say, whoever wants to use this downstream should handle these cases, the missing columns and things like that. Now, I think that we need to answer that question, because that can change our decisions downstream for other things. By the way, as a side note, I did also maybe 2 months ago, I did some experiments with DocDB, because it has nice features that you can just do an in-process Parquet querying, writing SQL, and it would be just included in our pipelines, for example, their pipeline controllers. There is a Jupyter notebook in our repo. I'll just put the link, which surprisingly, it was slow. Comparing with the Spark on a single machine, both of them on one single machine. But just, that aside, I'm expecting that, there would be tools that can't schema merging, especially in nested fields. So that's what I would guess. So then I think then it becomes to those three questions that, for example, do we want to have people write SQL against this Parquet schema, or no, that's not an expected use case, for example? Do we want, what are the performance characteristics of this schema merging? Do we care? And things like that.
Yeah. So from my perspective, I think one of the main sort of drivers of this group actually is to try and sort of get away from people writing SQL directly against a variety of things that are really hard to write SQL against and really non-standard. So like, yes, you can write SQL against, you can write it against any of those things, but it's really hard and it's impossible to standardize. Is the kind of, I think, some of the main findings from some of the earlier work that we did in this group. Hence why there is value in sort of having a sort of view layer that we can write view runner implementations over that can run in just about any sort of, technology stack and give you a use case specific view, which you then can run sort of standard SQL over and use pretty much any tool. So coming back to your use case thing. So what is the most appropriate sort of, should it always have like a really comprehensive schema to make it a bit easier to query via SQL on the other end? Even if we did that, is that really practical? Because like we previously talked about, you actually can't do that anyway, right? You still have to make some assumptions about limiting the fidelity of that in order to represent the full schema. And I'm just not sure that actually, although it might be slightly easier to query in this respect, that you can know that certain fields are going to be there, although you still need to be able to, for example, consume the FHIR definitions and all the rest of it, the other assumptions that we put around the capability of a view runner. It's still really, really hard. Right. And there's going to be a loss of fidelity, I think, if we put that assumption around it. However, if we say that we can fit the schema to the data and it is true lossless, you can query it yourself or you can use it with a variety of more value. But I think that it's still really early days on this and really still just kicking ideas around. I'd love to get anyone else's thoughts.
Yeah, also because we have only, 2 minutes left, maybe do we want to discuss how we want to proceed? Dimitri, I guess that's his hand.
I just have some question about data types. I just noticed showed us your data and data time. I agree, but I noticed like 38 precision, and it seems to be too much. Like, from where have you gotten this value? Because if consider like FHIR standard, for example, version 6 spec, if I'm not mistaken, it's like 17 digits after mol, it's like 17 precision, and before mol, you can have 18, I think.
How about we take, since we're right at time, take some of the more detailed questions offline and then just get to Bashir's point, if that's okay, because I know probably some people have to drop into, where do we want to take this as a next step, just organizationally?
I mean, my opinion, it would be, if not everyone interested in, who attends this meeting in this detailed discussion, it's a good idea to create like a separate working group and, maybe even meet more frequently and then come back with a more concrete proposal, especially because my teammate, like Chandra, who you met, he's in India. This time is actually terrible for him.
Should we? Yeah, we can set up a series of meetings for, at the best possible time, because we probably don't want to keep reusing this weekly meeting for this, even though this is really fascinating. So let me take that on to structure a little bit of a subgroup, and I'll keep you guys informed, and it'll be all public.
Excellent, thank you.
That'll work.
That would be great.
Thanks, Action.
Awesome. Okay. Yeah, I see we're a little bit over time. So thanks, everybody. Thanks especially to John. Yeah, really, really interesting work and excited to see it continue. So yeah, really, really appreciate it. And I think many folks do as well.
Thank you. Thanks, everybody.
Yep.
Have a good week.
Thanks, everyone.
Thank you.